Hello, everybody. Hey, this is a big deal here. This is your last chemistry assignment for your junior year. And for the MQ8 grade period, there are three things. There's Boyle's Law and Charles' Law, and this one right here, this ideal gas law. And really, it's just a matter of sticking in some numbers into an equation and getting an answer. And you may be thinking, well, I don't need to do anything for MQ8. School is done, and I can just rely on my Q3 grade. And yeah, that's right. But take a look at your Q3 grade. If your Q3 grade is sitting at a C, hey, take a few minutes and turn it into an A. Do those three things. They're fairly simple. I grade them fairly easy. I'm just looking for effort. Looking if you're trying to, expand your mind and learn a little bit of chemistry and show me some effort. So let me just explain what an ideal gas is, and you'll have access to this sheet. This is your assignment here that you're seeing, and it kind of explains it. It says over here that ideal gases are gases that when they bounce together in a tank, they do so elastically. In other words, there's a nice clean bounce. But if you look here, it says that molecules that are real, they tend to have a clumping as they prepare to go to a liquid. There's a little positive-negative interaction there. And so those are real gases. And if you look at this bottom thing, it says most gases are real when under high pressure and low temperature. So it's really a set of conditions that make a gas an ideal gas or a real gas. And really the crux of the ideal gas law is this equation right here, this PV equals nRT. Now P is pressure and V is volume and T is temperature. We've had those before. What is N? N is just the number of moles right here, number of moles. And what is R? R is a fixed number. We call it a constant. It's 0.0821. So wherever you see R, you just stick in that number, 0.0821. They're really quite simple. I've done an example problem right here at the bottom of the first page, and you may want to take a look at that. The only thing that might trip you up is watch your temperatures. If your temperatures are in Celsius, like in here, this is 1995 C, remember you would add 273 to that to make it Kelvin. Otherwise, on this sheet, you shouldn't have to do any conversions. And so the second page of this thing, it just asks you to look at these pictures and label them as ideal, real, or solid, or liquid. And number two, it just asks you what conditions make something real. Just kind of look at what I wrote up above. And then these equations right here, these four problems, there's just 6 problems in total. It asks you to stick some numbers into PV equals nRT. So like here it says a gas cylinder has a volume of 108. It's got an N of 2.32, and it's got a temperature of 456. What is the pressure? So I just took this thing right here. Notice it's not PV equals nRT. I just swung the V away from the left and underneath on the right to divide by V. And then you just stick the numbers in and solve. Listen, email me if you have any questions about this, and do yourself a favor, get an easy A, okay? This is our last assignment. I hope you're all doing well, and I hope you all have a good summer.